In the summer of 1936, workers digging near Kujut Rabu, just outside the ancient gates of Baghdad, uncovered a strange clay jar. The small yellow pot appeared unremarkable at first glance, buried alongside ancient graves from the Parthian Empire. Yet inside the sealed ceramic vessel lay a combination of materials that would baffle scientists for nearly a century. A rolled sheet of copper held an iron rod suspended in place by dark asphalt. When German archaeologist Wilhelm Koenig examined the artifact in 1938, he noticed something extraordinary about its design. The copper cylinder was sealed at the bottom with a disc of lead, while the iron rod hung down the center without touching the copper walls. The entire top was capped with bitumen, a natural tar that acted as a waterproof stopper. To a modern engineer, this design looked remarkably like a modern battery cell. Koenig proposed a radical theory that shocked the scientific community. He suggested that investigating the function of this simple jar revealed an ancient device for generating electricity. If filled with an acidic liquid like grape juice, lemon juice, or vinegar, the chemical interaction between iron and copper would produce an electric current. This became known worldwide as the scientific theory of the Baghdad Battery. To test this idea, modern scientists turned to experimental archaeology. They built exact replicas of the Kujut Rabu jar using similar metals and materials. By filling the copper tube with acidic liquids available during ancient times, researchers measured a distinct electrical charge. The test showed the replica could generate between 0.8 and 2.0 volts of electricity, proving that the basic design could act as a working galvanic cell. The creation of voltage in a laboratory proved the physics worked, but it raised a deeper mystery. What could an ancient civilization during the Parthian Empire actually use electricity for? One popular idea was the electroplating theory. Proponents argued that ancient craftsmen used small electric currents to coat silver jewelry with thin layers of gold. If true, it would mean advanced metallic plating techniques existed thousands of years before modern discoveries. Experimental trials demonstrated that several Baghdad battery jars connected together in a circuit could indeed gild small silver objects. Researchers successfully deposited fine layers of gold onto metals using replicas filled with natural acids. For a brief moment, the electroplating theory seemed to offer a complete explanation. The technical capability was undeniable, but historical evidence soon began to pull the theory apart under closer scientific examination. When experts analyzed actual gold and silver artifacts recovered from ancient Parthian sites, they found no traces of electroplating. Instead, these ancient ornaments showed unmistakable signs of fire gilding, a traditional process using mercury and heat. Furthermore, archaeologists found no copper wires, no switches, and no written records describing electricity or electrical currents anywhere in the vast historical archives of the region. Without wires or conductive lines, transferring electrical current from the jar to an external object would have been virtually impossible. The asphalt seal completely covered the top of the jar, locking the iron rod inside without exposed connectors. If the device was built as a galvanic cell, its energy was trapped inside the ceramic shell. This major structural flaw forced researchers to look for alternative explanations for the mysterious artifact. A competing theory emerged, suggesting the jars served a far more common purpose as sacred storage containers. In the dry climate of the Middle East, ancient people often preserved delicate parchment scrolls inside copper tubes. These tubes were then placed inside sealed clay jars to protect sacred texts from moisture, insects, and decay. Over time, the organic scroll inside would rot away, leaving behind only the iron rod that once rolled it tight. Archaeologists pointed to similar ceramic containers discovered at the nearby ancient city of Seleucia. These vessels contained organic remains and rolled metal linings, clearly functioning as protective cases for written documents rather than power sources. The presence of asphalt served as a simple sealant to keep air out, a standard preservation technique used across the region for centuries. The stark contrast between potential function and practical use divides modern researchers today. While experimental archaeology confirms that the jar can generate electric voltage under laboratory conditions, there is no proof that ancient artisans understood or intended this effect. An accidental chemical reaction inside a sealed scroll container does not equal purposeful electrical technology created by an ancient empire. The debate grew even more complex because scientists could no longer study the original artifacts directly. During the turmoil of 2003, the original Baghdad Battery was looted from the National Museum of Iraq along with thousands of priceless historical treasures. Without the original materials available for modern chemical testing, researchers must rely heavily on notes, photographs, and replica experiments performed decades ago. Despite the loss of the physical artifact, scientists continue investigating every detail of the surviving documentation. Modern microscopic analysis of photographs taken before the loss shows unique corrosion patterns on the iron rods. Some chemical analysts argue these rust patterns match what would occur in acidic liquids, while others insist the decay matches normal soil exposure over 2,000 years. The story of the Baghdad Battery highlights a crucial challenge in modern science and history. It is easy to project modern technical knowledge onto ancient objects when their shapes resemble our own tools. Yet true scientific rigor demands that an explanation must fit the broader culture, materials, and documented knowledge of the time, rather than isolated laboratory success. If the Parthian Empire did possess electrical knowledge, it left no lasting footprint in medicine, illumination, or communication. No ancient texts mention shocks, sparks, or energetic currents. Without written instructions or widespread adoption, any discovery of electrical generation remains an isolated accident of chemistry rather than a technological revolution that transformed ancient society. Engineers who study the replicas admit that the jar makes a remarkably inefficient galvanic cell. The bitumen seal prevents liquid from easily being added or replaced once depleted. To maintain an electric current, the vessel would require constant refills of acid, an awkward process that would break the asphalt stopper every time the battery needed charging. This mechanical inefficiency strongly supports the storage scroll hypothesis over the electrical power source theory. Ancient craftspeople were skilled engineers who refined their tools for practical daily use. If they intended to build a reliable power source, they would have created open, accessible designs with external terminal leads rather than permanently sealed ceramic pots. The scientific theory of the Baghdad Battery remains one of archaeology's most captivating mysteries, precisely because it sits on the edge of possibility. It proves that ancient materials could produce modern phenomena by coincidence. The jar demonstrates how simple chemistry exists independently of human understanding, capable of generating spark, even if those who built it were seeking only to protect their words. Today, the jar from Kujut Rabu stands as a quiet reminder of the boundary between what an ancient artifact could do and what it was truly built to achieve. Science has shown that the jar could function as a battery, but history reminds us that capability is not proof of intent. The mystery of Baghdad remains sealed within the clay, awaiting new evidence from the ancient earth.